Alright, Chapter 15, Automatic Block System, 1935, American Railways, American Association, American Railroad. Chapter 15, Automatic Block System, 3-block Indication System. Fixed signal with a 3-block system usually displays proceeds approach, medium of the approach, or the stop, and then proceed per indication depending upon the blocking condition. The fixed signal with the 2 operating units, 1 3-position unit above the 2 position of the 3-position unit with the 3-block indication with the system is named, but the region of the preceding indication can be given at least at 3 blocks in advance if such a signal is unoccupied. The fixed signal cannot be displayed in approach, medium, index until at least 2 blocks in advance if such signal is unoccupied. The fixed signal can be displayed in approach indication only when the block immediately advances. If the signal is unoccupied, the train accepting of such indication must prepare to stop at the next signal. 3-block indication signal is employed with where there is desire to increase the track capacity that is permanent to closer the spacing of the train, moving out of the preceding signal that would be possible with the track block indication signal system that would be recalled with the 2-block indication signal with the signal generally located braking distance apart with the minimum of the permit the train with the stop and then proceed with the signal with the movement of the authorized speed with the approaching signal. Take example the 3-block indication signal system with a speed signal of 1/2 mile an hour, half a mile an hour, half a mile apart compared with the 2-block indication signal system spaced 1 mile apart. The 3-block indication system approach indication will be displayed a half mile in the rear of the stop and proceeding signal, and approach medium indication would be displayed in a half mile with the rear of the approach signal system. A proceeding indication would display 1/2 mile with the rear of the approach of the medium signal. It'll be noted that the approach medium indication would be displayed with 1 mile at the rear of the stop. The preceding the stop at the same distance, but the approaching indication would be displayed with the rear of the stop. The preceding indication, preceding signal with a 2-block indication system. The display of an approach medium indication required with the train approaching with the authorized speed, but to reduce the speed to approach the next signal not exceeding the medium speed. The medium speed is approximately 1/2 of the authorized speed, but therefore the approach of the medium signal is not only the space sufficient distance apart, but the permit reduction of the authorized for the speed to medium speed. Distance between may be considered, but this being approximately 1/2 of the distance required to permit the train to stop. Authorized speed with the follow of the approaching signal should be located in sufficient distance with the stop and to proceed with the signal to permit the train traveling medium in the speed. If the approaching signal to stop and proceed signal, which is the distance considered approximately 1/2 of the braking distance and authorized speed. As evidence, the preceding indication would be displayed approximately 1 1/2 mile with the rear of the stop. At the preceding signal, where there's 2 block indication signal precedes the indication would be displayed 2 miles in the rear of the stop at the preceding signal. Therefore, the 3-block indication system receiving the 1 1/2 mile part will receive the preceding indication, where the 2-block indication system preceding speed must be spaced 2 miles apart in order to receive the preceding indications. Figure 5 illustrates the aspect displayed as the different signal when in a block occupied with the system of the 3-block indication signal system section, the double track signal system being normally clear. Normal clear searchlight signal with the direct control, neutral with the track neutral, and polarized line control. Figure 6 illustrates the searchlight signal with the use of the 3-block indication, normal clear color light signal installation, double track, and employing the direct control, neutral track circuit, the neutral polarized line circuit. The signal light mechanism circuit. Each signal mechanism of the 2 winding known as the field, the armature winding with the field winding of the energized with the continuous with the positive and negative battery B and C with connected directly to the positive and negative terminals. The armature winding will be energized through the contact with this signal controlled relay or HER or DR caused by either the yellow or green aspects displayed depending on the direction of the current. The circuit of the signal mechanism A230 with this is followed the positive and negative battery B and C with the normal reverse polar contact, the neutral form of the contacts polarized with the A230 HDR with the wires A230G and the NA230G to the armature terminals with the relay of A230 HDR with the de-energized armature de-energized with the signal will display the stop and the preceding indication relay A230 HDR energized with the reverse polar contacts of the closed, but the current will flow with the armature in such a direction to cause. Alright, this shows figure 3, the aspects displayed in the 3-block indication double track. And this shows the circuit of the 3-block indication normal clear search signal, double track, direct current, normal track, neutralized line current control circuits. Alright, signal display and approach medium indication depending on whether the relay B230DR is de-energized and the relay A230HDR is energized. Normal polar contact flows with the current flowing in the armature direction caused with the signal display of the proceed indication. The circuit of the signal mechanism B230 is the flow of the positive B battery with the reverse polar contact of the relay A230HDR and wire B230G1 through the front of the contact relay B230DR, wire B230G, armature wiring NB230G through the front of the contact relay B230DR on negative battery C. The reverse polar contact relay of the A230HDR to the open of the armature will be de-energized with the single display with any of the indications except with the approach depending on the position of the relay's controlling mechanism A230. Or a single repeating the relay circuit. The single repeating relay is HDPR for each of the signal energized with the signal display approach with approach medium with the proceed indication of the circuit of the relay, the A210 HDPR with the file with the positive B with the contact with the mechanism A210 with the close with the signal display with the approach medium with the proceed indication wire A210 HDP1 through the neutral contact relay H210 HDR wire H210 HDP through the coil of the A210 HDPR with the negative battery C. Show the release of the relay sheet with the signal repeating relay so that the front of the contacts remain closed with the indication chain with the approach medium with the proceed with the vice versa. Our signal controlling relay circuit. The signal control relay or DR with the B unit with any of the signal de-energized with the signal display approach medium with the preceding indication. The circuit of the signal control relay B220 DR is filed with the positive and negative battery B and C with the front of the contacts relay A210 HDPR with the front of the contact relay A220 HDPR with the control oil of the relay B220 DR. The signal control relay of the HDR with the A unit. The signal is energized. The reverse and the neutral reverse polar contacts are closed when all the track circuits between the signal and the next signal is advanced with the unoccupied and the signal advanced displayed in the stop and then proceed with the approaching indication signal control relay HDR with the A unit any with the signal can energize normal with the front normal neutral normal polar contacts are closed with all track circuits between the signal and the next signal advanced with the unoccupied signal advanced displayed approaching medium proceeding indication circuit relay A230 HDR is filed with the positive battery B through the coil of the relay 220 AR with the operation of this relay with explained later through the back contact of the relay B220DR through the front of the contact relay A220 TR over the front contact relay B220DR through all the contact track relays between the signals 230 and 220 through the coil for the relay A230 HCR over the front of the contacts with all the track relays between the signals 230 and 220 the front of the back contact relay B220DR to the negative battery C of the circuit of the energized signal control relay A230 HCR. It's first necessary all the track relays between signals 230 and 220 be energized in such a case that the direction of the current track of the coil to the polarized relay of the A230 HCR depends on whether the front of the back contacts relay of B220 DR are closed. With the back contacts relay of B220 DR are closed and polar armature relay of 230 HCR be energized in reverse with the front of the contact relays B220 DR are closed and polar armature relay of A230 HCR will be energized normally. Our front contact relay of the H220 TR is included with the control circuit of the relay of the A230 with the HER with the AR230 HER with the energized before the front contact of the relay B230 B220 with the DR with the open should be short train of the passenger 220 with the high speed through the preventing of the green flash on the signal 230. Our approach relay signal. The approach relay at the signal is connected with the series of the signal control relay HDR from the A unit of the signal in the rear with the energized, but only when all the tracks between the signal is located, but the first signal with the rear unoccupied, but the approach relay is energized. One of its goals is shunting the front contact resistance for the series, and the signal control relay is reduced accordingly. Signal light circuiting. When short spacing the signal of the system is desired for two signal and lighted with the advance of each of the train with the for each approach of lighting relay AER at each signal with the control with the front contact relays approach relay AR for the signal with the front contacts approach with the AR approaching relay for the signal in the rear. The filaments of the lamps of A and B units or signal are connected with the multiple positive B and the taken with through the back contact of the approach lighting relay AER with the lamp filaments with the negative battery C. Our double red indication system. The system is shown figure 7 with the fixed operating with the 3 position displayed proceed, approach, and stop, then proceed indication. Stop, then proceed indication is displayed at each of the signal control with the 2 black instead of 1. Sonar systems of this type should be used on subway, elevated railway lines, light trains, all operated with a high speed at frequent intervals among train stopping devices generally used in such a signal indication system. Figure 8 illustrates the circuits using normal control, normal clear color light signal illustration subway line where the trains are operated with a direct current through the signal system employing alternating track circuits, direct current neutral control circuits. Track circuits are a signal alternating current using double element relay, one relay acting as one cotton woman rail for the returning of the direct current with the propulsion alternating track circuit. Our figure 7 shows the aspects displayed in the 2 block indication double track, 1 block overlap. When a train occupying a block track protected with by a signal 2, the denoted with the signal 2 and 4 are displayed as stop, then proceed indication within 6, and then approaching indication signal 8, proceed indication. The system of the R space braking distance apart with the maximum speed, so the train is always protected with automatic train stop. At the stop and proceed signal 1 blocking the rear of the following the train should have passed the signal to stop and then proceed. Local element circuit. The local elements of all the track relays energized with the continuous BX55 and CX55 with the connection directly to the coil terminals. Automatic train stop circuit control circuits. The automatic train stop is assumed with the non-tripping position with the 2 track of the circuits in advance. Unoccupied assumed with the tripping position when either the 2 track circuits are occupied except with the which will not change with the non-tripping position. The tripping position while the track is in the rear is occupied, but ensure the train passing the signal will not cause the train stop. The signal to change with the non-tripping position. The tripping position entirely with the train has passed. The circuit of the train stop of the 6V as signal 6 is followed with the positive barrier of the B20 through the contact with the track relay 4TR with the 6TR through the coil within the 6V negative battery C20 with the battery B20 through the back contact track relay to 8TR through the contact is going to close with the train stop of the 6V of the non-training position with the coil of the 6V negative battery 6Z20. Single control relay circuit. The single control relay or HR with the controls approach the indication of the signal energized with the train stop of the signal is not tripping position. The true 2-track situation advanced with the signal or is unoccupied. The signal control relay or DR which controls the preceding indication circuit of the energized with the H relay as the signal advances and energized. The circuit of the signal control relay at signal 8 is followed with the positive battery, the AB20 through the front of the contact track relay 6TR and 8TR through the coils relay of the HR through the contact of the close with the train stop of the signal 8 with the non-tripping position negative battery C20 and positive B20 through the front of the contact 6HR with the coil with the relay HADR with the signal negative battery C20. Single lighting circuit. When the single control relay HR to de-energize with the red lamp will be burning. When the HR with the energize with the relay DR the de-energize with the yellow lamp will be burning. When signal control relays HR and DR energize with the green lamp will burn. The light circuit will follow with the signal 4 as follows: BX55 through the back of the contact relay 4 HR through the filament of the red lamp CX55 and BX55. Figure 9H shows the circuit of the 2 block indication normal clear color light signal double track 1 block overlap alternating control circuit alternating current track and direct current non-neutral line circuits. Through the front of the contact relay 4HR with the back of the contact relay 4DR with the filament yellow lamp CX55 and BX55 with the front of the contact relay 4HR with the contact relay 4DR through the filament of the green lamp CX55. Alright, single track systems, overlapping systems. Single track train movements in both directions signals are arranged with the permit the following movements to all opposing movements. For the opposing movements, the single control circuits must be so arranged to prevent the display of single indication that would permit opposing trains to enter the same block at the same time. The overlapping system is accomplished extending the control in the signal beyond the next signal in advance with the governing in the same direction. Figure 9 illustrates the control of an overlap system which is leaving the signal and sidings located in the clear points, but the signals are sometimes located at the switch. Figure 10 illustrates the circuit of the normal clear Sethmore signals achieve the single track overlapping system signal employing the direct current control neutral track of the polarized line control. Referring to figure 10 with the trains moving the opposite direction, one move with the westward and side marked A with the other eastward with the side marked B with the westward train with the A would receive the preceding indication in signal 7. Likewise, eastward train with a B would receive the preceding indication in signal 14. Westward signal 9 would display the preceding indication as would eastward signal 12. The westward signal 11, the eastward signal 10 will display an approaching indication because the westward signal 13 and eastward signal 8 are displayed to stop, then proceed indication signals 8 and 13 are displayed and stop, then proceed indication because they directly controlled over the track circuits not occupied with the train sidings A and B. The signals 10 and 11 are displayed an approaching indication, although none of the track of the circuits are involved. The control of these two signals are occupied through the polarized line relays controlling these controls of the reverse, and because of the control of each of these relays is taken through the pole of the changing contacts operated by the mechanism of the signal advance of the vice versa. Alright, considering the westward train leaving A with the passing signal 7, the approximate with the same time the eastward train leaving B with the pass to the signal 14, both of the train approximately at the same rate of speed. When the westward train each of the track circuit 7T, signal 7 would assume the stopping position. Likewise, the signal 14 would assume the stopping position. The eastward train entered the track circuit 13T, with each of the signals being controlled over the track circuit mentioned. The eastward and westward trains occupying the track circuit 7T and 13T. Signals 10 and 11 will assume the stopping position because each is controlled over the track circuit mentioned, but when signals 9 and 12 would be displayed approaching indication because of the control circuit of each is taken through the polar change of the signal's advance, which is displaying a stop then proceed indication. Alright, figure 9 shows the diagram showing the track limits, the signal control of the signal track overlap. Alright, 1 and 2 going from left to right to all the way up to 15, 16. The bottom side on your positives, the top side on your eastward, you're going westward. And then you have your figure 10. Your circuit signal track overlap 2 blocking 3 position signals F4 near normal clear direction neutral track and polarized line control circuits. As each train approaches the next signal indication of the opposing signal will not change with the eastward train, but they enter the circuit track of the A11T when the signal 9 will display the top of the preceding indication of the signal controlled by the track at A11T, will then cause the westward train to receive the stop and then proceed indication of the signal 9 will cause the eastward train to receive the approach of the indication of signal 12, then will cause the westward train to stop at the signal 9, permitting the eastward train to move to signal 10, but both the trains will be stopped, but the trains have stopped at the stopping, then proceed with each of the proceed under the rules governing the movement of the trains in such territory. Consider the true James same class approaching the siding B with the eastward train by being the superior with the direction will hold the main track, while the westward train will take the siding westward, and trains approaching with the signal 9 will display on the preceding indication track circuits the control of the signal being unoccupied. The signal 11 over which the control of the signal with the 9 pole is changed with the preceding. Likewise, the eastward train approaching the signal 20 will receive the preceding indication for the same reason. Our signals 11 and 8 are also displaying preceding indication because of the track of the other controlling circuit of these chains are unoccupied with the signal over which these signals are polar chains and also proceeding proceeds. Signal 13 and 16 also proceed because of the track circuit control of these signals are unoccupied with the signals over which the track the control circuits are pole chains to display an approaching indication westward train and the preceding indication of the eastward train. Alright, signal 15 displaying an approach indication with the eastward train with the occupied track circuits A19T, but because of the track circuits controlling the signal with the unoccupied signal 17. Over the control signal 15, the pole chain is displaying the stop, and then proceed signal 14 still displaying a preceding indication westward train occupying the track of the signal B7T with the track circuit controlling the signal, but the unoccupied with the signal 12 over which the control circuit the signal 14 is pole change is displaying an approach indication of the signal 10 with displaying a stop, then proceed indication. Signal 17 is displaying a stop, then proceed indication because of the track circuit A19T is occupied with the eastward train. Likewise, the signal 19 is displaying the stop, then proceed indication because of the track circuit A19T is occupied. Signal 12 is displaying an approach indication because of the signal 10 over the which for the control signal 12 is the pole change displaying a stop, then proceed indication. These reason the difference of the indication displayed in signal 12 with the signal 17 are located relatively in the same location with the approaching train. In the scheme of the overlap of the layout is such that the control of all over the westward intermediate signals is overlapped over the track circuit in advance the second opposing signal, thus giving the eastward train an advantage to the closing of the westward on the westward train. When the eastward train has passed signal 20, the occupying track circuit is 19T with the causing signal 20 display the stop then proceed indication. There will be no change in the indication of any of the opposing signals. However, when the westward train has passed the signal end of the occupying track signal circuit 9T with the causing signal 9 to display stop then proceed indication. The indication signal 12 with the change for the stop then proceed because the 12 is controlled with the track circuit 9T with the non-occupied with the westward train. Likewise, signal 14 will display an approach indication because of the control circuit. The signal 14 pull over the change over the signal 12. The other eastward signal indication remaining unchanged. For this movement, there's no further change for the indication display of each of the train tracks and track circuits and approaching the next signal in the direction of that they are moving. With the eastward train occupying the track circuit of the A17 17T with the signal 15 will display a stop and then proceed indication because of the track circuit. A17T control signal 15, thus turning the cause of the 13 to 11 display an approach with the indication because of the control circuit of the signal. 13 pole is changed with the signal 15 with the stop and then proceed position. Likewise, the control signal 11 is pole changed by the signal with the approach of the position. Westward train occupying the track circuit BT9. Signal 14 will display a stop then proceed indication because of the track. BT9 controls the signal 14. This in turn will cause the signal 16 and 18 to display an approach indication because the control circuit of the signal 16 is pole changed. The signal 14 is stop. Then proceed position. Likewise, the control signal 18 is pole changed by the signal 16 approach position. Attention is called to the fact that both signals advance, but the train is displaying an approach indication, otherwise known as a double approach to the meeting point. There's no change in the indication displayed by the signal until each of the trains occupying the track circuit is approached for the next signal with the direction in which they are moving. When the eastward train is occupied the track circuit with the A15-3T and A13 will display the stop then proceed indication because of the track circuit A15T and the control circuit with the signal 13 with the signal 16 is still displaying an approach indication, thus permitting the eastward train to pass through signal 16. As the westward train enters the siding of the B to permit the eastward train to pass the switch to the east end of the siding with the reverse allows the signal 13 to display the approach indication with the westward train to enter the siding by these means with the special circuit completed through the circuit controller connected to the switch. Consider two trains of different classes of the eastward train being superior with the westward train being entering the siding B. The occupying track circle the 13T with the switch reverse eastward train is approaching signal 16, displaying an approach indication due to the special circuit arrangement, and the control circuit from the signal 16 which operates as follows with the switch at least one at each the east, and set forth the siding. A special circuit is provided through the contact with the switch circuit control energized with the control relay of the signal 16. Special circuit nullified with the track occupant track circuit 13T with the that the track circuit B11T is clear for the entering the train directional traffic relay energized with the 16 FR, which keeps the control circuit from the signal 16 for the energized local long as entering the train occupying the track circuit 13T through the permitting of the train to set and switch to the main track movement without causing the signal 16 to change and approach to the stop and then proceed indication. This arrangement permits the eastward train to make through a movement without stopping the signal 16. As soon as the westward train has cleared the track 16 circuit 13T with the siding switch of the normal position, signal 14 will indicate the proceeding, permitting the eastward train to proceed. As soon as the eastward train has cleared the track circuit 15T, the signal 15 will assume the position westward train, carrying them, preceding them from the siding, accepting the indication of signal 15 authority with the proceed. No sidings again. Signals are provided with the installation and local wiring of each of the signals shown in Figure 11. Figure 11 shows the local wiring of each signal shown in Figure 10. Figure 12 illustrates the circuit with a normal clear lower quadrant set more signal for the use of the single track overlay system and employing the direct control direct current neutral track and line circuit. The installation with the controller arranged with directly from the use of those overlapping systems illustrated in Figure 9 and 10. The signals governing the training of the movement leaving the side blocking control with the corresponding signal to the next siding. For example, the signal 8 is controlled with the track circuit between signals 8 and 3. The signal 6 is controlled with the track circuits between 6 and 3. Therefore, the blocking space for the following train is on from the signal with 8 to 4 signal and signal 5 to 6 is installed with the protection opposing movement only should be the two trains for the passing 3 and 8 at the same time. It will also be noted that some of the signals in installation of the display have 3 indications, such as the signal 1, 4, 7, 10, while other signals display 2 indications 2, 3, 5, 6, 8, 9, displaying stop then proceed. Preceding indication signals D1, D4, D7, D10 displayed in approach and preceding indications. Considering a westward train leaving siding A with the passing signal 3 approximately at the same time, the eastward train leaving the siding B with the passing signal 8, signal 3, 5, 6, and 8 will now display stop then proceed indication. Therefore, each train will receive the stop then proceed indications of the signal 5 and 6. Alright, this shows the circuits of single track overlap 2 and block indication normal clear 2 position, sophomore signals direct current neutral track line control 6 circuits. Alright, and then I'm going to quit there and come back to this tomorrow. Page 28.